Hello guys, welcome to my channel Engineering Insights. So in this video we are going to see about the double groove pulley assembly which is in my hand. You can see all the views of this double groove pulley assembly here. So this double groove pulley assembly consists of four parts, which is the first part is major is cover, and the second part is the pulleys. Third part is that you can able to see a separator in between of these two pulleys to have a distance between them. And the fourth one is the rivet pin which is going to connect the pulleys along with its cover. So this double groove pulley assembly is also called as a double sheave pulley, where it is used to transfer the loads from one point to another point using the belts and ropes. Since we have two grooves in it, it is helped to distribute the load equally on both the pulleys and reduce the wear and tear on the pulleys. So the major parameters of the double groove pulley assembly are: the first parameter is the outside diameter of a pulley. You can able to see the maximum diameter of the pulley, which is called as the outside diameter of the pulley, and this is called as the groove width, the distance between the end face to and another end face. So the second parameter is the first to groove, the distance from the end of the pulley to the mid plane of the groove. If for example, if the material of this edge is 2 mm and the groove with this 5 mm means the 2 mm plus this 5 divided by 2, so 4.5. This distance is called as the first groove width. So these are the major parameters of the double groove pulley, and this double groove pulley assembly is majorly used in household applications, gym equipments, and some industries as well as for the machineries. So guys, so next we are going to see how to create a CAD model for this double groove pulley assembly. Let's see the CAD model. So guys, as we discussed in the live session on the double groove pulley assemblies, here we are going to start a CAD model creation of it. So I'm using Creo 7.0. One by one, we are going to create the models of it, and later we will get it assembled. That is called as a bottom-up design methodology. I'm going to use a top design methodology, where we are just going to create a assemble file first and creating the child parts in it using publish geometry and copy geometry, which will be more helpful to create the next step models. So we'll start. So I'm clicking on new button, selecting assemblies, and I'm renaming it as double grooved pulley. So in this I'm creating a part name this cover. It's empty. So I'm opening this part in a separate window. So first I will add planes, and I will start from modeling. As we saw in a live session, double groove pulley assembly cover is made in sheet metal where the thickness is very less. So I'm converting this into sheet metal and click OK. So I'm selecting the extrude feature, selecting a plane, moving to sketch view, mark the center lines, a vertical line and horizontal line. Yeah. Let this distance as 30 and distance as 15, and we'll make this into symmetry for the vertical line and click OK. So thicknesses I'm getting 1 mm, and the profile of the material is getting developed inside the sketch. I'm flipping this direction so it will be get outside of the sketch, and the bend radius in the internal radius I'm making, which is equals to thickness as of now, I'm making into 0.5. Yeah. So this looks good. Next I'm going to create an extrude cut. I'm selecting these edges or surfaces for the references, solve and close. Sketch view. I'm creating a center line, a tangent line in left and right hand side, and the same line mirrored in the left hand side, and the extra lines to cut the material. So these extra lines are need to be deleted. I'm selecting delete segment line and just drag here wherever I wanted to remove the lines. So this is a profile which we need to create. Making this 15, this is 5. This distance doesn't matter, this is not into picture. So it can be as any value. I'm expanding this to some distance. I need also I can able to get this, and I'm selecting this feature which can be cut. So now I'm going to create a hole. Before creating a hole, I'm just measuring the distance between the top surface to this center point of the circle, which is 13.5. So I'm going to create a same hole at the distance of 13.5. So I'm going to create a hole, selecting the surface. I'm enabling the planes. So this will be as 13.5. I'm making this as 0, or else let it be as 12 as of now, but later I will make it as 0. The reason is in extrude I'm going to change it to symmetric option. So the total distance, which is 22.5, I'm making it as 30 and making this profile to be as a symmetric. So the hole which I'm creating for the clamping the pulleys will be at the center. So this will be as 0. And the diameter of hole will be as 3. Yeah, fine. And the depth of the hole. Depth of the hole also needs to, I need the hole should be come until this end of the surface. So instead of being selecting some distance, I'm selecting until this surface, and I'm selecting the surface, so the hole will be generated through all. And another two more holes in the top. I'm selecting this. One will be on this exactly 0 of this plane. Second one will be at some distance. So the total distance is 30. I'm going to keep it as per side, it will be as a 15. I'm going to keep it as 4.5. Yeah. And this hole will be as 2. And click OK. The same hole will be mirrored on the opposite side. I'm selecting the mirror command and selecting this plane. And I just click OK. So we got this cover profile. So to avoid sharp corners, I'm adding this fillets in this edges for the radius of 1. So I hope so. This looks good. I'm changing the color also. Let it be as a black. Yeah. So as I told to you, are using a top-down design methodology, public geometry is one of the major important feature at the end of the profile, which we are going to use it in the end. In desktop, I have created a folder double grouply and I will save it there. And this double grouply also will be saved in the same folder. Next, I'm going to create a pulley. So before going to create a pulley, I'm just activate this pulley part, and I'm get this publish geometry as a copy geometry inside the pulley part, which will be very useful to create the pulley setup. So after creating this, inside the pulley, you can able to see a copy geometry file of this curve. I'm just creating a planes, default planes, and I'm going to create a pulley. I'm selecting a revolve command, moving to sketch view. So here the references I need as this face I need it as reference, this face I need as a reference, and this profile also need as a reference. So to make sure the pulley center hole and the cover hole is on the straight line, I'm adding a center line or axis line here, and I'm going to create a pulley structure. I'm just creating a rough sketch as of now. Later, by modifying the dimensions, we will get a perfect profile. Maybe this line is a vertical, so I need this line as a 2 mm. This line also to be as a 2 mm. The distance between these two should be as 6. Or let it be as 8. Not an issue. So the next is the angle inclination of this profile will be as 120 degree, and the same way here 120 degree. Distance between the end of the surface to this will be as a 1 mm, and the half diameter will be as 3 mm. And this profile I'm going to create is a circle. And I'm deleting the unwanted lines. So here we can able to see a pulley on the left hand side, which is good. As same, I'm just going to add a fillet on the sharp corners on the both sides, and an entry chamfer for the pin, which is zero point 0.5 into 45 degree. Make this into a 45 into D. Will be as a zero point 0.5. Yeah. So next, we are going to create a. I'm adding. Let me another round for these edges at the range of zero point 0.1. Yeah. So next we are going to give color for this as a pink color. We'll go with metallic. Yeah. So here you can see the distance of this, and the in front view, and in front view also the profile looks good. Yeah. So we'll make it as publish geometry. So one thing need to be remember when we are using publish and copy geometry. After you use such a copy geometry for reference for the next profile, always make it to hide condition and click on save status. So this part will be saved in this same particular status at multiple use. Next, I'm going to assembly profile itself. The same pulley needs to be assembled on the right hand side also. The distance between this surface to this cover surface is 1 mm. The same way I'm going to assemble it once again. Going to assemble model, selecting this pulley. I just select this profile to be as a coincidence, and the outer surface of the pulley and the inner surface of the cover should be have a distance of 1 mm. Yeah. So the next thing is we need to create a separator in between of this. So we'll go for it. I'm creating another new file, which will be as a separator. To this, I'm adding both pulleys as a references. Let me hide one set of copy geometry where it will be useful for me to add features. So here we can able to see this plane as a center one. That's the plane where I'm going to create a profile now. So to that I'm selecting an extrude feature, and I'm selecting this particular plane and moving to the sketch view of it, adding a center lines on both horizontal and vertical direction, as well as on the center point of this circle. The same way I'm going to create a profile which will be equals to this. This was a tangent, and the same line will be mirrored on the opposite side. The extra lines will be removed. I'm going to increase this height as 12 and this length as 20. Okay. Extrude will be as a 2 mm as a symmetric. We'll make it as 4. Yeah. Or let it be as 2 mm itself. And I'm going to create a hole as same as what we did in the pulleys and the cover to be enable this display and display. As of now, I have added to the hole as 2 mm from the vertical distance. Let me verify whether is it okay or need to be modified. To verify it, select this hole and this hole. Check the distance between of it. It is 0.5 mm offset. So when you see the profile hole in the support is 0.5 mm offset below to the comparing to the hole in the pulley. Yeah. So I'm just going to modify this hole command and increasing this as 2.5. And click OK. So the distance between this hole center to pulley hole center will be as same 0 mm. It's good. This also changes to the color black. and I'm publishing it is not required. I'll hide this copy geometry, save status, and save this file and close it. Yeah. So the next thing is the final part, which is we are going to add a revert point. To add that, I'm creating another one new file. Like this. In revert, I'm going to make this active and getting a fully copy geometry there. Open this in a separate file, adding the planes. I'm just going to make a normal extrude for the revert, and I'm taking this circle as a reference. Length will be as 32. Since for cover we have given us 30, giving a revert as 32 so that 1 will be offsetted out towards outside in the main assembly. For revert, I'm going to give it a okay. Let me increase the extrude of revert for even 2 more mm. It's of 32, I'll make it as 34 and click OK. So here, as you can see, the double groove pulley assemblies, which is did in a CAD model and with the separator, and these two holes will be used to clamp the double groove pulley assemblies with a frame using a M screws. So guys, as you like this video, please give a like button and give your comments on the comments box, and please share it with your friends who are very interested to learn in the CAD models and the mechanical insights. So we'll catch you in the next video. Take care. Bye.